Okay, this is number 31, and here we're going to find the inverse Laplace transform as opposed to the Laplace transform, right? So far we've been working with, right, we're given an f of t, right, and the goal is to find the Laplace transform, right, of that f of t, right, which we call capital F of s, right? So that's what the last few problems in the videos were about, right? To go from here, so from here to here, let's see, maybe, right, that was taking the Laplace transform. Well, now we're going to start with f of s, and we want f of t, so, I mean, that's going the other way, so that's going to be the Laplace inverse of our f of s. Okay, so that's the idea. So let's go ahead and start this. So the Laplace transform of f of s, right, this guy, and my f of s is, let's see, 10s minus 3 over 25 minus s squared. Okay, so we can definitely, I'm going to simplify, and actually I'm going to, well, I'll go ahead and work to the right. I can break this fraction up, right, into two fractions. I can say 10s over 25 minus s squared minus 3 over 25 minus s squared. And again, we're trying to break this this expression up into simple expressions so we can use what we know. Again, what we, in this case, we're trying to look for our capital F of s's that are in the right-hand column on page 271. So, right, this means this, and using, and actually that should be inverse, right? And we can use the linearity property for inverses as well. And I see some constants here, so we can definitely take those out. So I'm going to rewrite this as, let's see, let me maybe move this over. So I have, so equals, I'm going to write 10 times the Laplace inverse of s over, and we know 25 is 5 squared. So I'm going to go ahead and write 5 squared minus s squared. And again, these are my s's, right, and that's a 5. Let's see, minus 3 times the Laplace inverse of, again, so 1 over 5 squared minus s squared. Okay, so we go back to our table, and, you know, we ask ourselves, do I see, right, this expression, s over, right, some constant, maybe k squared minus s squared? And so I'm looking at the table, and we have an s, I'm looking at a hyperbolic cosine, and it looks like s over s squared minus k squared. But here I have, so this is s, and the formula has s squared minus k squared. Well, I can bring my s technically, I can kind of modify this, but I can't just switch it without doing something. I can say s over, and I can rewrite this as negative s squared plus 5 squared. Right, that's the same thing, right? I haven't changed anything. But I can, again, factor out a negative 1 because I want my denominator to have a subtraction sign right here because that's what hyperbolic cosine is. And I'm looking at hyperbolic cosine because I have an s here, right? If it was k, then it would be sine. So I'm going to go ahead and, right, I can factor out a negative 1 there. So s over, right, I'll just write it out here. So s squared minus 5 squared minus 3 times, and okay, well, while I'm working on that one, let's see, do we see this one? 1 over maybe k squared minus s squared, and again, that's going to be very similar. I want my k first, so even just to save some time, we can say this is going to be, I'm going to factor out a negative 1, right? Just like I did here, because it's the same expression, right? I have 5 squared minus s squared, 5 squared minus s squared. So we don't have to do the work twice. Well, let me go ahead and move this over a little bit. And I have s squared minus 5 squared. Okay, so I have 10 times the inverse transform of, and this negative 1 here, I'm just going to go ahead and bring it outside, right? So that's going to make this negative 10. And now I have s over s squared minus, and then that's a 5 squared, minus, and I'm going to bring that negative out there. And that's going to be plus 3 times the Laplace, the inverse transform of 1 over s squared minus 5 squared. Okay, so we're almost done. So now, do I see this guy in my column? And, well, I have s over s squared minus k squared, where k is 5. So this guy is definitely going to be hyperbolic cosine h of kt, and so my k in this case is 5, right? So we're looking for that f of t, so here's our function of t, and I'm multiplying by negative 10, of course. And finally, right, do we see this guy? And looking at our table, okay, so we have, let me get my pointer here, so we definitely have our s squared minus k squared. So I'm looking at hyperbolic cosine or sine. Well, it's not cosine because I don't have I don't have an s here, but I also don't have a k here, right? It's either an s or a 5. And I don't have a 5 there, so I can't just say hyperbolic sine of 5t. But, I mean, we're allowed to, kind of manipulate this. I can say, or hopefully you agree with me when I say 3 times the Laplace inverse of, and I'm going to go ahead and multiply by, actually, it's the same thing, but I'm going to multiply by 5. Okay, so I have s squared minus 5, that's a 5 squared, and then I'm going to multiply by a 5th, or divide by a 5th. Now, I want you to see that I didn't really change anything, right? Because I multiplied 5 over 5, I multiplied by 1. So that doesn't change the value of this expression. And the reason I did that, so let me just go ahead and copy this. We can write it in parentheses if we want, 5t plus 3. And then I want to look at this guy. Do I have this expression? And now I do. I have k over s squared minus k squared. So that is definitely going to be, let's see, so I have plus, so it's going to be sine h of 5t, right? But I have to multiply by that 5th, right? Or if you want to divide it by 5, right? I still have that 5th there. And again, we use this property a lot when you first learned about integration and like in your calculus 2 class. So that's pretty much it. I don't think there's any really simplification here. That is your f of t. So let me just go ahead and write this guy is your f of t, right? Which, I mean, you computed the Laplace inverse, or inverse transform of capital F of s. Okay, so you end up with the function of t, right? So you're just going the other way.